Dear learners, myself Dr. Rajiv Prasad, Academic Officer Chemistry from NIOS, and I am dealing with the chemistry subject at the Science and Technology course. Today we are going to learn about the atomic structure, which is chapter number 5. After completing this lesson, you will be able to recall the evidence showing the presence of charged particle in matter. You will be able to describe the discovery of electron and proton, explain Dalton's atomic theory and its failure, discuss Thomson's and Rutherford model of atom and explain their limitations. Explain the Bohr's model of atom in brief, describe the discovery of neutron, compare the characteristic properties of proton, electrons and the neutrons, explain various rules for filling of electrons and write the distribution of electron in different cell up to atomic number 20. Define valency and correlate electronic configuration of an atom with its valency. Define atomic number and mass number of an atom. Describe isotopes, isobars. Define and compute average atomic mass and explain its fractional value. Dear learners, you know that according to Dalton's atomic theory, the atoms of different elements are different, and in chemical reaction the atoms are rearranged between different reacting substances. However, today we know that the atom is not indivisible as it was thought by Dalton. The atom has a structure and contain smaller constituents in it. In this unit, we will attempt to find out the answer of some of the questions like what is the structure of an atom, what are the constituents of atom, why the atoms of different elements are different, and so on. We will begin this unit with the study of discoveries of subatomic particles such as electrons, protons and neutrons. Then we will take up various atomic models proposed on the basis of these discoveries. We will discuss how various models of the structure of atom were developed and also explain the success as well as the shortcomings of these models. This will be followed by description of the arrangement or the distribution of electron in the atom. This arrangement is known as electronic configuration. Charged particles in an atom. Towards the end of 19th century, certain experiments shows that an atom is neither the smallest nor the indivisible particles of a matter as stated by Dalton. It was shown to even a smaller particle. These particles were called electrons, protons and neutrons. Discovery of electron. In 1885, Sir William Crookes carried out a series of experiments using cathode ray tube. A cathode ray tube consists of two metal electrodes sealed in a partially evacuated glass tube, and evacuated tube is the one from which most of air has been removed. The negatively charged electrode is called cathode, whereas the positively charged electrode is called anode. These electrodes are connected to a high voltage source. Such a cathode ray tube has been shown in figure below. This is the overall arrangement for the cathode ray which produces the negatively charged particles, which is later called as electron. Properties of cathode rays. Following are the important properties of cathode rays. First, cathode rays are a stream of fast moving particle. These particles have a negligible mass, but travel very fast. They carry negative charge and later called electrons. The nature of cathode ray generated is independent of the nature of the gas filled in the discharge tube as well as the nature of metal used for making the electrode. This is the arrangement for production of cathode rays, which is shown here. Cathode ray as pass through the electric field and their deflection is shown. Discovery of proton. Goldstein performed an experiment using a discharge tube similar to cathode ray tube. Here a perforated cathode was used and was fixed in the middle of the discharge tube. On applying a high voltage, a faint red glow was observed behind the perforated cathode. This is the arrangement shown in this figure. The glow was due to anode rays, which are a stream of positively charged particles originated at the anode and moving towards cathode. The glow is produced when these particles strike the glass tube behind the cathode. Properties of anode rays. First, anode rays are a stream of positively charged particles which were later called protons. Second, these particles are much heavier than electrons. Third, the positive charge on the particles was whole number multiple of the amount of negative charge present in the electron. Fourth, the nature and type of the particles constituting the anode rays were dependent on the nature of gas present in the discharge tube. Discovery of neutron. The discrepancies could be resolved if an electrically neutral particles with mass nearly same as that of proton was also present in the nucleus. Such a particle was discovered by James Chadwick in 1932, which had no charge and whose mass were nearly same as that of a proton. It was named as neutron. Characteristic of fundamental particles. This table shows the different particles, electrons, protons and neutrons, their symbol, mass, charge, etc., and their actual charge in coulombs is also mentioned here. Atomic models. Conclusions drawn from the discovery of electron and proton. Atom consists of positively charged particle which carries practically the whole mass of the atom. Second, negatively charged electron which have a negligible mass. Third, the total positive charge is equal to the total negative charge. Now, see the first model, Thomson's atomic model and its main concept. According to this model, an atom can be considered as a large sphere of positive charge with a number of small negatively charged electrons scattered throughout. This model is also called plum pudding model. This is the actual arrangement given by the Thomson, where a sphere indicates the positive charge and the negative charge is embedded or scattered in this sphere. Rutherford alpha ray scattering experiment. This was the second experiment to find out the actual structure of the atom. Alpha ray scattering experiment was designed to experimentally verify Thomson atomic model. In this experiment, a stream of alpha particles from a radioactive source was directed on thin foil of gold. Alpha particles are helium nuclei obtained by removing both the electrons from helium atom. This was the arrangement by Rutherford gold foil experiment. The results of alpha ray scattering experiment. First, on the basis of this experiment, Rutherford concluded that most of the alpha particles pass straight through the gold foil without any deflection. Some of the alpha particles were deflected by small angles. A few particles were deflected by large angles. About 1 in every 12,000 particles experience a rebounds. On the basis of this observation, Rutherford model is like this. First, an atom consists of a dense and positively charged region located in its center called nucleus. All the positive charge and most of the mass of the atom are contained in the nucleus. The rest of the atom is empty space in which a small negatively charged electrons revolve around the nucleus. Now, after this Rutherford atomic model, there was also some drawbacks. The drawbacks of Rutherford model was like this: the stability of atom, that means Rutherford model do not explain the stability of atom, that is the actual position of electrons and protons in an atom. Distribution of electron around the nucleus, it was not mentioned in this model that where is the specific position of electrons and protons. Relationship between atomic mass and atomic number, that is also not explained by the Rutherford atomic model. These were the main drawbacks. This picture depicts that when electrons start revolving around the nucleus, it will radiate energy and ultimately it will collide with the nucleus, which shows the instability of the atomic model given by Rutherford. Now, after the failure of Rutherford atomic model, Bohr proposed his atomic model and its important postulates are like this. First postulate: the electron moves in defined circular path of fixed energy around a central nucleus. These paths are called orbits or energy levels. Electrons moving in these orbits do not radiate electromagnetic radiation. Such orbits are also called stationary states. Here the different stationary states are indicated and their different cells or orbits are represented by the symbol KLMN. Second postulate: the electron can change its cell or energy level by absorbing or releasing energy in the form of a single photon of radiation of appropriate frequency given by the relation E h nu, that equal to E f minus E I. When the electron change its initial energy level with energy E 1 or you can say E I to the one with the final energy E f. This is the actual representation of exchange of energy when the electron changes its orbit. Now, the next concept is atomic number and mass number. Atomic number is equal to number of protons, that is equal to number of electrons for the neutral atoms. Mass number, it is equal to number of protons plus number of neutron, that is equal to total number of nucleons. Atomic number and the mass number are represented on the symbol of an element. An element, suppose X with atomic number Z and the atomic mass number A is denoted as, for example, carbon 12 6, it means that the carbon has atomic number 6 and the mass number of 12. This can be used to compute the number of different fundamental particles in the atom. Let us calculate its electrons, protons and neutrons for the carbon. As the atomic number is 6, this means number of protons, that is equal to number of electron, that is equal to 6, because it is a neutral atom. As mass number is equal to number of protons plus number of neutrons, we put the relation here 12, that is equal to 6 plus number of neutrons, then we get the number of neutrons is equal to 6. Thus, of an atom of C12(6)C has 6 protons, 6 electrons and 6 neutrons. Electronic configuration, that is followed by a rule or a scheme called Bohr-Berry scheme. According to this rule, the cell is an atom are represented by the letters K, L, M, and that should be the capital, or by the positive integers n is equal to 1, 2, 3, 4, that represents the number of cells, the first cell, second cell, third cell, fourth cell, etc. Rule 2, the maximum number of electrons that can be accommodated in a cell is given by the formula 2n square, where n is the number of cells. Rule 3, the cells are occupied in the increasing order of their energies. That means, first cell 1 will fill up, then cell electron will go to the second cell and third cell, so on. Rule 4, the main group elements can have a maximum of 8 electrons in their outermost cell. This table indicates the sum of the values of electrons, maximum electrons capacity of a particular cell, K cell, L cell, M cell, N cell, as per the formula. They contains 2, 8, 18 and 32 electrons. This is the representation of electron filled in different orbits in the different elements. Now, the next important term is valency. Valency is the combining capacity of an element. It is also the number of chemical bonds that an atom can form with the univalent atoms. Valency of an element can be taken as the number of atoms of hydrogen with which one atom of element can combine. Valency and the number of valence electron, these are the two important terms. Let us understand this. Valency of an element is governed by the number of its valence electron. If the number of valence electron is 4 or less, then the valency is equal to the number of valence electrons. In this case, valency is equal to number of valence electron if the electron is less than valence electron is less than 4. If the number of valence electron is more than 4, valency is equal to 8 minus the number of valence electron. For example, valency is equal to 8 minus number of valence electron whose valence electron is more than 4. These are the representation of different elements, their symbol, their atomic number, their valence electron and the distribution of electrons in different cells. Dear learners, let us recapitulate what we have learned in this chapter. According to Dalton's atomic theory, the atom is considered to be the smallest indivisible constituent of all matters. This theory could explain the law of conservation of mass, law of constant proportion and the law of multiple proportion. However, certain experiments towards the end of 19th century show that the atom is neither the smallest nor the indivisible particle of matter. It was shown to made up of even smaller particles called electrons, protons and neutrons. Sir J. J. Thomson discovered that when very high voltage was passed across the electrodes in the cathode ray tube, the cathode produce rays that travel from cathode to anode and were called cathode rays. It shows that the rays were made up of a stream of negatively charged particles called electrons. The discovery of electrons meant that the atom is not indivisible, as was believed by Dalton and others. Eugene Goldstein discovered anode rays by using a perforated cathode, a cathode having holes in it, in the discharge tube fitted with air at a very low pressure. the discovery of anode rays established the presence of positive charge proton in the atom. According to Thomson-Plum-Pudding model, atom can be considered as a large sphere of uniform positive charge with a number of small negatively charged electrons scattered throughout it. The alpha ray scattering experiment performed by Zeiser and the Mardashian led to the failure of Thomson's model of atom. In this experiment, a stream of alpha particles from a radioactive source was directed on a thin piece of gold foil, which is also known as Rutherford Goldfield experiment. Most of the alpha particles passed straight through the gold foil. Some alpha particles were deflected by small angles and a few particles by large angles, and the very few experienced rebounds. The result of alpha ray scattering experiment were explained in terms of Rutherford model, according to which the atom contains a dense and positively charged region called nucleus at its center, and negatively charged electrons moves around it. All the positive charge and most of the mass of atom is contained in the nucleus. The Rutherford model, however, failed as it could not explain the stability of atom, the distribution of electron, and the relationship between the atomic mass and atomic number, the number of protons. The problem of the stability of the atom and the distribution of electron in the atom was solved by Niels Bohr in terms of Bohr's atomic model. Bohr's model can be understood in terms of two postulates. The first being electron moves in definite circular path of fixed energy around a central nucleus, and the second is the electrons can change its orbit or energy level by absorbing or releasing energy. In 1932, James Chadwick discovered the electrically neutral particle in atom and named it as neutron. The number of protons in an atom is called the atomic number, and it is denoted as capital Z. On the other hand, the number of nucleons, that is protons plus neutrons in the nucleus of an atom, is called its mass number, and it denoted by a symbol capital A. The electrons are distributed in different cells in order of increasing energy. That was the Bohr's postulate. The distribution is called electronic configuration. The maximum number of electrons present in a cell is given by the formula 2n square, where n is the number of the orbit or the cell. The valence is the number of chemical bonds that an atom can form with univalent atoms. If the number of valence electron is 4 or less, then the valency is equal to the number of the valence electrons. On the other hand, if the number of valence electron is more than 4, then generally the valency is equal to 8 minus number of valence shell electrons. I hope you have understand the main concepts of atomic structure. So, start solving assignments related to this chapter, and you can also send us your queries at aochm@nios.ac.in. Good luck and best wishes.